Hello and welcome to the Friction Atwood machine video tutorial. Here we have a 15 kilogram block resting on a table being pulled by a 4 kilogram mass. We're going to solve for the acceleration of this block. First thing to do is to draw a force diagram. So the table is pushing up on the block. Gravity is pulling down on the block. The hanging mass is pulling the block to the right, and the block is experiencing friction from the table, preventing motion to the right. So the top force is the normal force. The bottom force, a little shorter. The bottom force is the force of gravity. The force to the right, we're just going to call that force. That's the force of the hanging mass pulling the block to the right. And the force to the left is the force of friction. We're going to try to draw these to scale, and to do that we're going to assume that the block is not accelerating up or down. So force of gravity and the normal force should be about the same. And because it implies that the block is accelerating, we are going to start that this force from the hanging mass is larger than the force of friction, otherwise the block would not accelerate. So first thing we're going to do is we are going to determine if the block actually does accelerate or not. To do this, we're going to try to find out if this force is larger or smaller than this force. So first thing to do is figure out what is this force pulling the block to the right. Well, the block is being pulled to the right due to the force of gravity on the hanging mass. So this force here is equal to the mass of this block times gravity. So that's 4 kilograms times 9.8, and that's equal to 39.2 newtons. So that's the force being applied by the hanging mass on the block. So now we're going to compare this force to the force of friction on the block. So the force of friction is equal to normal force times the coefficient of friction. In this case, we're going to be looking at the static coefficient of friction because we want to see if the block even moves at all. So the static coefficient of friction implies that the block is not moving. So, but to do this, we need to solve for Fn. So we're going to have to use a force summation equation and use our force diagram to get Fn. So the sum of forces in the y direction is equal to the up forces minus the down forces. And because the block is not accelerating up or down, this will be equal to 0. So we need to get Fg. So the force of gravity on that block is equal to the mass of that block times 9.8. So the mass of this block is 15, and times 9.8. That's going to equal 147 newtons. So there's your Fg. We can take this and plug it into this equation now. So Fn is unknown. And if we subtract Fg, which is 147, we are going to get 0. So Fn is 147 newtons. All right. Now that we know that the normal force is 147 newtons, we can plug it in here to get our force of friction. So the force of friction, static friction to be specific, is equal to 147 times, well, we need to use our static coefficient of friction, so 0.2, and that is equal to 29.4 newtons. Alright, so the force to the right is 39.2 newtons, and the force to the left is 29.4 newtons. There is more force to the right than the left, therefore the block will accelerate to the right. So because the block is accelerating to the right, that means that we should have never used the 0.2 newtons, and that's an inaccurate value, because since the block is moving, we should be using the coefficient of kinetic friction, because kinetic friction is for when the block is moving, static friction is for when the block is not moving. So to figure out the true force of friction, which should be less than this value, we'll just change this to the coefficient of kinetic friction. So now this is force of friction kinetic, which is 147 times 0.15, and that's 22.05 newtons. So this is our force of friction kinetic as opposed to static. So next thing to do is a summation equation left and right. So the sum of all forces in the x direction is equal to the right forces, which is just F, minus the left forces, force of friction kinetic. And because the block is accelerating in the horizontal direction, this will not equal 0. This is going to equal mass times acceleration. So the force is 39.2, and the force of friction kinetic is 22.05, and that's going to equal mass times acceleration. So the question comes, which mass do you choose, the block or the hanging mass? Well, it's the entire system that is accelerating. So because the entire system is accelerating, you need to use the mass of the entire system. So that's 15 plus 4. So that's the mass of 19 kilograms. So times the acceleration. So let's see, 39.2 minus 22.05 is 17.15 newtons. That's going to equal 19 times the acceleration. So 17.15 divided by 19, and the acceleration of that block is 0.903 meters per second squared. Thank you for watching the Friction Atwood machine video tutorial.